This is how we use GeoScout to find a perfect location for your community-owned wind energy. We're selecting the town of Langscope, just for the example. We select a turbine. In this case, it's a 4.2 megawatt Vestas with a hub height of 82 meters. We can select the turbine spacing, but I'll leave it as default, but you can customize this. I'll go for a fixed radius around the town that I pointed out. I can choose the radius. I'm going to stick with 10 kilometers. And my objective is balance, which means I'm going to balance the power of the wind with the amount of neighbours that might be impacted or disturbed by having a turbine nearby. I could say zero impact on neighbours or minimal, or I could favour wind output. But let's go with balance for the example. So this will take a minute to load. We're looking at power lines, grid capacity, Natura 2000 sites. We're looking at the cadastral land ownership data, and we're working through around 30,000 plus permutations of where we could locate these two turbines. And then GeoScout is going to show us a ranked list of optimal locations, taking into account different factors within the Orklys algorithm. Okay, so we've run the analysis and 200 proposals have been generated by our algorithm. Let's have a look at them. Okay, so first of all, we can clean up our map. Let's get rid of some of this stuff. Okay, here is the coastal zone. People say that you should not build within 2 kilometers of a coastal zone, but you can see it's a bit more complicated than that. It's bigger in some places than others. It's not necessarily uniform. So here's the coastal zone we want to avoid. Here we have our ranked locations. There's quite a few places we can build. Here's a number 1 rank for this town. We found a place that impacts 0 people within 4 times the turbine height, 5 neighbours within 6 times the turbine height, and only 15 within 8 times the height. The lower you go down, the more people are impacted. Balanced with the wind, I should say. Okay, so I can actually sort by wind output. This would be the best place if you looked just at the electricity energy produced. This is minimizing the impact, and this is the objective I selected at the beginning. So this area, this location has 34% of the world's wind power passing through it, pretty good, and not many people impacted. Now, what else can we tell about this location? First of all, it's not anywhere near the Natura 2000 sites. Second, it's not anywhere near the power lines. Third, it's not too far from a substation. Whoops. Okay. Let's have a look at where people live. This is the houses. You can see a cluster here and a cluster here. And these are all the potential sites that we've analysed. Okay, now all we need to do is work out who owns the land, and we can go and see if we can make an agreement with them. So you can see that we've managed to plot the turbines in this cadastral layer, which is owned by the same person. So we only have to deal with one landowner across these parcels of land, which is great. And that landowner owns 433 hectares of land in this area. Okay, we can have a look at the satellite and also the terrain view. Now, terrain in Denmark, things are quite flat. So this might make more sense if we jump over to Spain. So here in Spain, we've done the same thing. You can see we've got a lot more wind. 75% of the world's wind power coming through here. That's not total wind power, obviously, but in terms of like the highest speed wind in the world, in Spain you can find 75% of the strength. And you can see when we look at the terrain that we've plotted this on a ridge. Okay, so we've taken into account the wind power here, and this is an excellent area. Similar thing, here's power line, quite far. Urban zones, quite far away. The addresses in this region of Spain. Natura 2000 sites, which we've managed to avoid. You can see over here the wind is coming from the south. If you need to edit these, you can. You can click on each turbine and look at the amount of energy that's going to get produced every year. This is 35,000 megawatts. If we go and have a look at this on the Orklys website, there's a calculator. 35,000 megawatts is 35 gigawatts. Based on average consumption, you can power about 10,000 homes with that one turbine. Amazing, right? So there you have it. GeoScout location finder, helping you identify where to build your community-owned wind turbines.